Okay, let's start. So, good evening, guys. So, yesterday we have stopped up to the topic, angular velocity and angular acceleration, right? Yes. So, we were saying about the angular velocity. So, the formula was omega is equals to d theta by dt, right? So, if we see the SI unit, no? So, we know the SI unit of velocity, right? It is meter per second, right? Okay. So, meter per second, whereas for angular velocity it is radians per second. Okay. So, similarly when we talk about acceleration, right? Acceleration is meter per second square. Similarly for angular acceleration it is radians per second square. Fine. Yeah. So, angular acceleration is nothing but alpha is equals to d omega by dt. So, we have a relation that is v is equals to r omega for linear velocity and angular velocity, right? If I differentiate dt, dt with both side, what happens here? dv by dt is equals to r into d omega by dt, whereas dv by dt is nothing but acceleration and d omega by dt is nothing but alpha, that is angular acceleration, which is nothing but r alpha. Okay, this is the relation for linear velocity and angular velocity, and this is the relation for linear acceleration and angular acceleration. Abdul Rahman, good evening. Okay. So, next we are talking about moment of torque. Okay. The vector product of position vector and the force acting on the particle is known as torque. Okay. So, torque formula is nothing but R cross F, where torque is a vector quantity. Okay. So, when we do a cross product, the resultant will be a vector product. When I do a dot product, the resultant will be a scalar product. So, for a dot product, we will get RF sin theta, cos theta, right? For a cross product, we will get RF sin theta. Okay. So, when we talk about sin theta, no, right, sin theta, sin angle increases from 0 degree to 90 degree, right? 0, 1 by 2, 1 by root 2, root 3 by 2, 1. Yes, na? Is this value increasing or decreasing? Increasing. So, when I talk about this value, if angle increases, value also increases, right? So, the component of the force perpendicular to the position vector gives the rotational about the fixed axis, right? So, they are saying that torque is equals to, like, R is perpendicular for the force, right? Yes, sin 90 degree. Okay. If R perpendicular is the R is the perpendicular distance of a line of action, F forms the origin. Okay. And one more thing we know, like, if torque is equals to 0, when we will get torque is equals to 0? When the angle is 0, right? Angle is 0, or else force is 0, or else position is 0. Okay. Take a note of this. Done. Can we go for the next one? Okay. So relation between torque and the angular momentum, right? So L is equals to R cross P. So what is P? Like what is angular, the momentum formula?
MV.
M into V, mass into velocity. So differentiating with respect to time with the both the sides, no, dl by dt is equals to d by dt of r cross p, right now. So we will get, if we take into inside, no, what will happen? Dr by dt into p plus r into dp by dt. So what is dr by dt? Velocity. What is dp by dt? Force, na? Yes, no? Yes. So dl by dt is equals to velocity into momentum plus position into force, right? So v into mv, like when we talk about momentum, mass into velocity plus r cross f. Okay. So when we can get a value 0, v cross v, which means I cross I equals to 0, j cross j equals to 0, k cross k is equals to 0, right now. So r cross f is nothing but the torque. Okay. So the relation between the torque and the angular momentum is nothing but dl by dt. Okay. This total value becomes 0.
Here L is angular.
Yes. L is the angular momentum. Okay. So the rate of change of angular momentum is equal to the external torque acting on it. So have you completed the worksheet? The worksheet, homework worksheet, whatever the work you have done yesterday. So similarly, whatever the things you are doing now, try to maintain that, okay? So whatever, like if you are doing 12 questions or 15 questions or 20 questions per day, like whatever the things, DPPs or achievers or whatever beginner PYQs. So if you are doing 2 PYQs means mention under 2 PYQs 2 questions has been done. If DPP is there means DPP has been done, okay? Okay. Yeah. So rate of change of total angular momentum of a system of a particle about a point is equal to the sum of external torque acting on a system taken about a same point. Right now we have talked about the momentum, rate of change of angular momentum with is nothing but a torque. So here the rate of change of angular momentum, like total angular momentum of a particle. So each particle will be there, no, I am clubbing everything, will be equal to the sum of a torque acting on a particles, na, each particles, right now. So L will be equals to L1 plus L2 plus up to Ln. It is summation of from I equals to 1 to n, that is Li, right now. So will be equals to the torque, right? Yeah. So give your worksheet here. So the thing is the chapter, okay, whatever chapter. For example, we are going with the system of particles, na? So if DPP is done, so DPP as they have mentioned, no. So whether you are doing DPP 1, 2, 3, whatever it is, mention the DPP question number in bracket. Okay. So NCERT beginner means how many questions you have done. Achievers means how many questions. Okay. And then master strokes and then PYQs. Okay. Yeah, like minimum it can be up to yourself. Okay. So minimum of do 15 questions, 15 to 20 questions of each subject. Okay. So if you are doing 20 from physics, 20 from chemistry, 20 from botany and 20 from zoology. Okay. So approximately 80 to 100 questions, try to complete it per day. Okay. So it should be minimum of 80 questions. Maximum you can do how many questions you want. Okay. So everything should be done and you should get a signature of your parents right side. Daily. Yes, daily. So while starting the class now, get a signature from the respective faculties and maintain a separate note for whatever the things you are doing. Yeah, we'll go for the next one. So next is conservation of angular momentum. If the total external torque on a system of a particle is 0, then the angular momentum, like total angular momentum of the system is conserved, which means constant. If there is no external torque, yes na, is 0. I mean, if there is no external torque, a particle is 0. On a particle is 0, which means total angular momentum will be constant, right now. So we know that torque, external torque is nothing but change in angular momentum with respect to time, na? Yes. So if external torque is 0, so dl by dt will be 0, where L will be constant. So Abdul, are you taking notes? Okay. Go for the next one. Yes. Here is the question. Show that the angular momentum about any point of a single particle moving with a constant velocity remains constant throughout the motion. Okay. So for that we will consider a particle moving with a constant velocity at point P. Okay. So consider another arbitrary point which is Q. So angular momentum about Q is nothing but L is equals to R cross mv, right. So L is equals to mv r sin theta, right now. So L is equals to mv r sin theta is always constant. Okay, take a note of this. We'll go for the next one. Done. Done. Okay. See, so direction of L is perpendicular to the plane of R and V. So it is into the page of the figure, right now. It is going inside the figure now. So from the scroll which is right hand rule now. So this direction does not change with time. So L remains the same in the magnitude and the direction, and therefore it is conserved. Okay, can we go for the next one? Yeah. So the next topic is moment of inertia. Okay. So it is the measure of a resistance of a body to angular acceleration about a given axis. Okay. So the formula is I is equals to, for if we consider n particles. Okay. So formula is I is equals to m1 r1 square plus m2 r2 square plus up to mn rn square. Okay. So it is I is equals to summation m r square from I is equals to 1 to I is equals to n. So SI unit is kg meter square. So dimensional formula for this is ml square t power 0. Okay. So the moment of inertia for a rigid body depends on mass of the body, shape and size of the body, distribution of mass about the axis of rotation, the position and orientation of axis of rotation. Okay. Done. So inertia is depends on mass of a body, shape, size, distribution of mass, position and orientation. Fine now. Okay. So next is rotational kinetic energy. Okay. So we have talked about the kinetic energy, right? So kinetic energy, it depends on the motion of a body, na? So we know the formula, that is of mv square, where m is the mass of the body and v is the velocity. Okay. So now we consider a body rotating about a fixed axis. So kinetic energy of a motion of a particle is of m I vi square initially. Okay. So we know that velocity in terms of angular, right now, linear velocity and angular velocity are omega, right? Can I substitute those value here? So of m into r omega the whole square, right now? Yes. Now if I take kinetic energy is equals to of mv square, where v is equals to r omega, so it is half into m into r omega square whole square, right now? So half into m into r square omega square. What is m into r square? Moment of inertia, right? So can I write kinetic energy is equals to of I omega square, right now? So we are getting the value, no? So this is kinetic energy in a rotational form. Okay. Done. And we go for the next one. Completed? Okay. So moment of inertia for the thin ring. So consider a ring of a radius r and mass m rotating about in a own plane. Okay. Around its center with an angular velocity omega. Okay. So each mass element of the ring moves with a speed of v is equals to r omega. So the kinetic energy will be summation of m1's v square up to mn square. No. So we are considering n number of particles. So each particle having mass m. Okay. So if we substitute those value now of mv square, which is nothing but of m r square into omega square. So comparing both of them, we will get I is equals to m r square for the thin ring. Okay, and we will see the some of the important objects moment of inertia. Okay, you can take a note of this. Done? Okay, we will go for the next one. So radius of gyration. So radius of gyration, which is denoted by the letter K. So the relation between the radius of gyration and the moment of inertia is nothing but I is equals to mk square. So we can write K is equals to root over I by m, where I is the moment of inertia and m is the mass. So where K is the radius of gyration. So it is as if all mass of a body A is concentrated at the distance K from the axis. Okay. Completed. So here is the moment of inertia of some regular shaped bodies about a specific axis. Okay. So the first one we are talking about a body, second part is a axis, and the given figure is there, and moment of inertia formula. Okay. So first one, thin circular ring of a radius r. Let me take a pen. Okay. Thin circular ring of a radius r, and axis, if you see, perpendicular to the plane at the center. Okay. So if we consider this is the ring, okay, this is the ring, the axis is perpendicular to the plane at the center. Okay. So the moment of inertia is mr square. Okay. So if we talk about the moment of inertia and the radius of gyration, no. So what will be the radius of gyration for this one? So K is equals to root over I by m. So moment of inertia of the ring, we know that mr square, right? So mr square by m, which is in the under root. So I mean r square, m and m will get cancelled. So radius of gyration is r. Okay. So the particles, everything will be in the center, concentrated at the center. Okay. So next one, if we see a thin circular ring, same, but the axis changes here, that is diameter. Okay, that is diameter. So formula is mr square by 2, mr square by 2. Now the radius of gyration will be k is equals to root over I by m, right? Now yes, so it will be equals to root over mr square by 2m. So m and m will get cancelled. R by root 2 is my radius of gyration for the second one. Okay, third one, it is a thin rod of length L. So here the axis is perpendicular to the rod at a midpoint. Okay, for this the moment of inertia is ml square by 12, ml square by 12. So k will be equals to root over I by m, right? Now I by m. So substitute the value of I there, which is nothing but ml square by 12m. So L by root 12 will be my radius of gyration for the thin rod in the axis of, axis is nothing but perpendicular to the rod at a midpoint. So for a circular disc of a radius r, so perpendicular to the disc at the center. So formula is mr square by 2. So radius of gyration will be k will be equals to root over I by m, whereas I is nothing but mr square by 2 into m. So it is r by root 2. Take a note of this. So Abdul, have you taken the notes? Abdul Rahman. Okay, Abdul, we'll go for the next one now. Okay, so the next one, okay, circular disc of a radius r, axis is diameter. Okay, so moment of inertia is mr square by 4. Next one, if you see, hollow cylinder, radius of r, and the axis is of the cylinder. Here it passes over the cylinder, it's perpendicular, okay, and it is mr square. Next, if you see solid cylinder of a radius r and axis of the cylinder, so it is mr square by 2, mr square by 2, and a solid sphere of a radius r and its diameter, through the diameter is the axis. 2 mr square by 5 is the moment of inertia. Okay, yeah. So now if we want to find the radius of gyration for these cases, no, so k will be equals to, I will write over here. So for the first one, so k is equals to root over I by m, where I is equals to mr square by 4, no. So m r square by 4 into m, right? So m and m will get cancelled off, which will be r by 2. So what about this case? K is equals to root over I by m, which is nothing but root over m r square by m. M and m will get cancelled. It is r, radius of gyration for the hollow cylinder and axis of the cylinder, for the axis of cylinder. When we see the solid cylinder, moment of inertia is mr square by 2. So radius of gyration will be root over I by m. So I is mr square by 2, right? So mr square by 2 into m. So m and m will get cancelled. It is r by root 2, right? So radius of gyration for the last case, what will be the answer? K will be equals to root over 2 mr square by 5 into m, right? So it is root 2 by 5 into r is the radius of gyration for the circular disc, hollow cylinder, solid cylinder and solid sphere. So Abdul Rahman, have you taken the notes? Kunal, completed? So next one, what we are seeing is theorem of perpendicular axis. So we are considering a body which is a planar body, okay, and Iz, I mean moment of inertia in the z axis is the moment, I mean at the point O, okay, at the point O. So where Ix and Iy are the moment of inertia of the two perpendicular axes through O lying in the same plane. So the theorem applies to flat bodies whose thickness is very small compared to the other dimensions. Okay, the formula is Iz is equal to Ix plus Iy. So moment of inertia in z axis will be equals to moment of inertia in x axis plus y axis is the perpendicular axis theorem. You can take a note of this. Done? Okay. See here. So what is the moment of inertia of a disc about one of its diameter? That is the question. Okay. So in moment of inertia of a disc which is passing through the perpendicular the plane no is nothing but mr square by 2. Okay. So m is the mass of a disc, r is the radius of the disc. So by the theorem we know that moment of inertia in z axis will be equals to moment of inertia of x axis plus y axis, right? No, so any of the two axes means x axis and y axis both are same, no? So can I say that moment of inertia of x will be equals to moment of inertia of y? So I can say that moment of inertia of z axis will be equals to 2 times of x axis or 2 times of y axis, right? So I need to find either x or y, no? So moment of inertia of x will be equals to moment of inertia of z axis by 2, which is equals to mr square by 2, no? Mr square by 2 will be equals to mr square by 4, right? So for moment of inertia of a disc about any of its diameter is mr square by 4. Take the equation, write down. Okay. So next one is parallel axis theorem. Okay. So the formula for the parallel axis theorem is the moment of inertia, the thing we know in the z axis, right? So let me take consider a body of a mass m whose center is at O. So let I in the z axis be the moment of inertia in axis which is passes through point O. So let I z dash be the moment of inertia of the same body about axis, that is z dash, and z dash is the parallel to the z axis. Okay. So here this is z axis. So z dash is the parallel thing I have taken. Okay. So at this point what will be the moment of inertia I need to find out. Okay. So the formula is I z dash will be equals to I z plus m a square. A is nothing but where the point I have taken to the point O is the distance. Okay. So where A is the distance between the parallel axis, that is z axis and z dash. So moment of inertia of a body about any axis is equal to the sum of moment of inertia of a body about a parallel axis passing through its center of mass and product of its mass and the square of a distance between the two parallel axes. Okay. Take a note of this. Are we done? Okay. So here is the question. Okay. So what is the moment of inertia of a rod of mass m, length L about an axis perpendicular to its through one end? Okay. So simple thing, guys. Here we know that moment of inertia of a rod, right? So moment of inertia of a rod from the center, no, what is that formula? ml square by 12, right? No. So the distance between from this point to this point is nothing but L by 2, no? L by 2. I need to find either in this or in this case. either any end I need to get it. So what is the formula? Moment of inertia, that is new moment of inertia, will be equals to old moment of inertia plus m a square, a distance from the parallel axis, right? So ml square by 12 plus m l by 2 the whole square, to the whole square. So which is equals to ml square by 12 plus ml square by 4, right? So I need to take the LCM. So ml square, so I will cross multiply it, 4 ml square plus 12 ml square divided by 48, 48 na. So 16 ml square by 48. So 16 ml square by 48. So once, and this is 3 times. So 1 times and this is 3 times. So the answer is ml square by 3. Done? Okay. So this was the answer we got now, ml square by 3. So here is the question. This is homework question, okay? So this is the homework question, guys. So what is the moment of inertia of a ring about a tangent to the circle of the ring? So tangent to the circle of the ring. Okay. So this is the homework question. You can take a screenshot of this question, and whoever here know, you can write the question. Get the answer by the next class. So guys, try to fill the worksheet which we have given and the things whatever you have completed, no, okay? Don't write the things you have not completed. So minimum of 20 questions you should complete per day. Okay. So we'll end this session. So get the answer, guys. Okay, get the answer of this question. So Rahman, Abdul Rahman, you have taken the question. So by next class, try to complete the question. And we'll check the answer in the next class, okay?